Welcome to the Energizing India podcast. Amara Raja built one of the world's greatest lead-acid battery businesses. Today, in 2026, it's attempting something far more difficult to build its life around lithium cells, lithium batteries, and battery energy storage, at a time when global supply chains and geopolitics are colliding all at once. 3 years after Vikramadithya GOURINENI first joined us on the Energizing India podcast, his plans have now become factories, cell qualification lines, and real capital risk. Today, on this program, we ask him the question underneath the gigafactory headlines. Does India have what it takes to dominate and master lithium cell manufacturing in India? Vikramadithya, welcome to the program.
So thanks for having me. 3 years has flown by. A lot to share with you today.
Vic, when we met in 2023, we discussed how a legacy battery company could reinvent itself before technology disrupts it. Here we are 3 years later. Your first factory is ready. Your customer qualification plant is up and running. You've committed major capital. How has that journey been? And do you still think that you might have gone too early? Or after having discovered how difficult it is to make a cell, you're asking yourself why you bothered?
So I think it's been a lot of learning. So actually in the 3 years it's been since we met, a lot of things I would have said to you last time, I've changed my mind on, or we've learned a lot more on. I think the positive is that we're a lot more confident about getting into cell making today than we were 3 years ago. I think last time we spoke, there's probably a lot of doubt or even skepticism in me, but we're making these big plans and we're talking about it, whether it can really happen. Gigafactories were still like rocket science to me back then. So when I walk through them now, when I start to understand, how things fit, what kind of decisions we should be taking, I think things are making a lot more sense. But with that said, I think we underestimated the challenge of kind of doing it, just without a partner, by going, by ourselves and not having a developed ecosystem, ready-made ecosystem around us. So when we got into the lead-acid battery journey at that time, Exide was already quite a large company. They're well established for many decades, even before we entered. So finding people who can work in the industry, getting access to material, other things, that wasn't the biggest challenge. The biggest challenge was going and challenging a large incumbent player. But in this case, we're going to be ending up competing with large incumbents who are, importing into India without having any of the necessary ecosystem around us. There are some developments on that front. So I think I'm happy, even since the time you visited, us in Hyderabad, that there's a lot more announcements coming on the material side, not so many on the equipment side, which gives us a little bit of a bother. But from a talent, technology, definitely we're quite confident that this can be done in India.
So what did you learn along the way in the last 3 years that you could not have possibly known in 2023 when you started down this adventure?
I think the main lesson is that, even when we want to, let's say you want to pursue a technology partnership, and, even the logic is very, in line with why we got into, lead acid, how we got into lead acid battery. Both times, whether it's for industrial battery, automotive, we always felt that technology collaboration can be a catalyst. If these are technologies that have been well developed, and especially lead acid is more than 100 years old, almost 200 years old. If people have already done it, rather than starting from scratch, trying to develop everything yourself, recreating the wheel, as you will, going with a partner who has established customer connect, supply chain, this is easy, right? So we tried to go for technology partnerships. And I think more and more technology is going to be wielded like a weapon, because in today's day and age, especially now with AI and other things coming in, technology is an edge, right? It's not something that you can give away easily. It's not even about military technology, even civilian technologies, like nuclear power was something that nobody wanted to share, right? I don't think obviously battery technology is quite at that level of sensitivity, but it's definitely not something that anyone was going to hand on a silver platter. So I think we had a lot of optimism that technology partnerships could be the right way forward, that could catalyze efforts. That hasn't worked out, unfortunately. But the learning now is that you have to put in the hard yards on the R&D. And second, even if you end up buying a technology, even if you end up getting everything told to you, you can't buy capability.
True.
So until machines break down for the first time on the shop floor, and our operators figure out how to solve the issue, it's not something that can be, you can't write an SOP, right? You can't just look at an operating manual and figure that out. And what we've tried to do the last couple of years is just build as much capability as possible. So with the CQP, it's a very early start, But the idea is institutional memory is something that we've been talking a lot about at Amara Raja. If we look at our lead acid factories also, there may be operators working for 30 years. Actually, by the time they retire, we don't even know what we're losing, right? The muscle memory he has in fixing a very specific calibration error on a machine is not something that's been written down anywhere. So hopefully with some of the technology you mentioned like AI and other things, maybe we can start to actually build this out a lot more, make it a lot more intuitive, system-based. But I think these are probably the main learnings. We're not going to cut short the learning curve.
I will come back to the technology partnership in a bit, but I want to just close out the loop on the learnings. What has been the hardest part? Has it been the chemistry, process controls, or the yields of the factory equipment, maybe talent, people reproducing the same cell exactly the same way a billion times? What's been the most difficult part of this 900-day journey?
Well, I'll answer it in two ways, because from cell manufacturing, CQP, we're very early, right? This is early days, hardly the last few months we've been really doing trial production. But even something as simple about pack manufacturing, appreciating why laser welding is superior in some cases than not, appreciating the need to use plasma to clean the the tabs of the cell. These are very small things. Appreciating why to go for automation in certain areas, why not to go manual in certain areas, and these are not things that any partner will just sit and tell you, right? Because these are actually things for them that's also second nature. Everything is subconscious. So I think for us it's just been going through trial and error over and over. This pack line we're sitting next to doesn't look very complex, but it does reflect a lot of learnings that we've had along the way. Now, coming to cell manufacturing, I think the number one thing, and we're lucky that we're going from an R&D lab to a qualification plant and then to Giga, because you're quickly learning that a lot of things that made sense at a lab level, they're just not manufacturable, or they're not manufacturable within a reasonable cost. So we have to go back and tinker with design. We have to go change certain things that make it more amenable to manufacturing at mass scale.
And all of those are things that you picked up along the way without this technical collaboration. When we spoke in 2023, a year after, Amara Raja announced the Goshen InnoBat technology partnership. Then we met in 2025, and there were some hiccups because of what China had done with the refusal to let Chinese technology come to India. How difficult was it for you at that time? You must have had sleepless nights. You've committed all of this capital, and suddenly geopolitics takes over. Talk me through that process. What did you go through, and what were the resolute decisions that you made coming out of it?
I think fortunately for me, while it might have felt a bit more like an existential crisis at the time, short career, for others in the organization, they've seen a lot of this happen before. So I think the number one thing was that, like I said earlier, a partnership was never the end all be all. So the idea was always a partnership can help you get off the blocks much faster. It can serve as a catalyst. But eventually, if you don't build real capability in-house, that you're never really going to make it in the long run, right? In the lead acid industry, we had a partner like Johnson Controls for a very long time. But aside from the initial kind of technology sharing from probably 1999 to 2001, everything you see today that makes Amaron is actually largely invented within India, right? Largely optimized within India, redesigned. So I think even when we took a step back and we saw, okay, what would we have done if we didn't have a partner, even in an earlier industry like lead acid? We would have taken longer, but we would have still done it, right? So part of our plan was always to build out, this R&D lab of a large R&D ecosystem, as well as a CQP, which we believe we've had to front end the investment a lot, given that we're not going to be depending on an imported technology immediately. So making the R&D investments very upfront, making the investments on talent also, front loading everything, bringing people on earlier. And I think with that said, we're not expecting overnight results. By bringing the talent earlier, it still takes time, right? It may take a year, it may take 2 years before really a lot of IP is generated in Amara Raja, a lot of our own efforts yield fruit. But the idea is if we don't do it now, maybe I'll meet you in another 3 years and I still won't have an idea what we're doing.
So Vic, you've taken some bets. Your first product is the 2170 cylindrical NMC cell, and the market is kind of fascinated with LFP. Yet you want to go down the road of standardization. So before I asked the question on standardization, why the 210 NMC cylindrical cell?
So I think like I'll park the bit on standardization, but I think the beauty of a cell when you look at it, it's not just the chemistry, right? There's the chemistry portion, which is the internals, but there's also the form factor. And I know if you look at 2170, it's a standard like what's a double A battery, right? A double A battery is not the chemistry inside. It's just the fact that everything around it has been built to suit that battery size. It's just become standard everywhere. And 2170 is as much a form factor, it's as much a size standard than it is the chemistry. So I would put aside the NMC chemistry. Probably today, I still believe in the short term, it's going to be make up the bulk of the chemistry required for Indian two-wheeler application, because they are looking for energy density. You just don't have the kind of real estate on board that can immediately switch over to only LFP and lose some of the things that NMC does well. The fact is, it's not one chemistry is better than the other. Both do very different things. NMC does owe to higher energy density, faster kind of charge, discharge kind of rates. But with that said, I think even when we go to LFP, it's not that you can just suddenly introduce a dramatically different cell. So regardless of the chemistry, I think the pack sizes are more or less the same. The packaging study will yield the same results. So with LFP, you might want to go for a bigger cell. In some cases, OEMs are saying, give me the exact same cell, just put LFP in it. So I think for us, chemistry is not it's not a decision that's set in stone. If tomorrow we have to change chemistry, we have to go to not even LFP, we have to go to sodium or something even different, right? We're happy to do so, but I personally believe in the 2170 form factor.
Any color you want, as long as it's black. So you're going down this. I guess the thinking process is like semiconductor, standardize as much as you can so that you can get economies of scale moving forward. I'm interested also, you have the two-wheeler, three-wheeler, and eventually the four-wheeler. You said you don't want to do customization right now, so I guess that'll push you into the two and three-wheeler segment to start with. But the bigger opportunity, and you've spoken about it as well, is battery energy storage. And Amara Raja is looking at that. Do you see BESS actually overtaking demand for your equipment, or for your batteries, over electric vehicles?
So in the short term, very much. I think that if you look at the way that BESS has kind of grown up in a very short period of time, actually you can say that we did it very late, right? Because we started with the massive rollout of renewables, and we kind of waited to a point where there was issues with grid. And I think this summer, for the first time, we actually started testing our grid. Probably, fingers crossed, we passed, right? But with that said, I think the next couple of years, you'll start to see BESS installations that far outweigh EV in India. And for Amara Raja, I think, like we said, when we want to go for standardized, we want to go for tried and tested, we want to go for something with broader application, the type of cells that we choose for, whether utility scale storage, the same cells can be used for residential storage, they can be used for a wide variety of applications.
Absolutely. So your best solution, is that an integrated solution? Are you looking at doing the thermal management as well as the PCS, the EMS, or are you staying with the batteries and wanting to provide any systems integrator the opportunity to use your batteries to be a BESS player?
So the goal is actually, and we're building a factory here, actually. So by the end of the year, we'll set up the initial capacity. We're looking at ultimate capacity of 10 gigawatt hour of full-scale systems. So that includes everything from the cells, the packs, the power electronics, the control electronics, obviously in phases, because not everything is like immediately there with us. But the idea is, I think, one of the risks we faced when we're trying to become an independent cell maker, you do have a fair share of OEMs in India who say they want to get into their own cell manufacturing. Similarly, you have a lot of people who want to backwards integrate, right? That's the name. So with ESS, we end up being the OEM, right? We don't have to then go sell that to anybody else. So immediately, if we're able to, on the back of our background in battery, our background in systems, if we're able to go sell 10 gigawatt hour of BESS solutions, tomorrow that's 10 gigawatt hour of cell, I don't have to now worry about who's going to do the offtake.
Exactly. It's quite amazing. I'll come back to the first principles on your journey again. In this, a lot of people talk about supply chain, and that's usually access to lithium, cobalt, manganese, all the other things that you need to make a graphite, to make a lithium cell. But beyond that, and we spoke about this 3 years ago also, it's the equipment, which is typically Chinese, but also the skill sets, the training that also rests in China. How have you overcome that, or how are you going to overcome that if you haven't yet?
So I think on equipment and material, it's a different story than the know-how, right? Know-how, like I said, the learning curve is the learning curve. If you bring a lot of people who, if you bring a lot of technicians from China, they can help smooth certain things over. But it also actually serves as a bit of a crutch. Even with CQP, what we noticed is, as long as they're there, they're running the machines, they're running the production, things are looking, relatively better. The second they're out of the picture and our team goes in and does the first couple of batches of production, it it looks really bad initially, right? But actually that's learning curve. I don't think that's a bad thing. Suddenly yields drop. Suddenly, things are not going optimally. But by the time, they come to the second, the third, the fourth, every subsequent time, it's getting a little better, right? And to the point that if they don't go through that learning curve, that struggle, it's not something, I think we keep saying it. You can buy technology. You can't buy capability, right? The capability has to be earned. So that's not, to me, something that I don't call that a challenge. I call that natural. That's something we have to go through. Now, material and equipment, let me be very blunt. I think equipment is not something I see enough movement. I don't want to say any, because I'm sure there's some people working hard and trying to do it. There's a couple of companies that are trying to innovate on very new processes also. But I think we'll have to give them their time to kind of, grow and develop their processes. But on material, I'm very happy to say a lot more friends have joined the fraternity, right, of battery making. And people who a couple years back were maybe only ideating at the time, I think in some cases they're not even waiting for us to set up capacity. Some companies are saying, okay, let the cell makers in India take however long they're going to take. We're going to start selling to the world. So that way I'm quite encouraged. In the CQP already, we are using a couple of local materials. I don't want to share exactly which ones yet, but to do our batch production. And I would say, to be cautiously, just to be abundantly cautious, day one manufacturing at the Giga, we can say we'll still be dependent on imported material. But if we're able to sneak in a couple of our friends and use local material for that, I think there's definitely some possibilities.
So I guess lithium from Australia and a lot of the others coming from India is what I'm assessing from this. Let's talk about the cost of manufacturing in India. I've seen some of the press work that you've done, and you said that an Indian cell will anyway be 15 to 25% more expensive than a Chinese cell. Do you think the Indian industry understands that energy security is worth paying this premium for, or are you hoping to get to a scale where you'll be able to compete with the Chinese, even if it's 3-4 years from today, and you just deal with whatever it is in the meantime?
So I think whether it's anybody on the value chain downstream of us, whether it's our immediate customers, the end customer, I think everybody appreciates the fact that eventually, if you really want to be sovereign as a nation, you have to have your own technology, you have to have your own supply chains. Now, with that said, if you ask my personal opinion, they would much prefer a mandate be given to localize, so that they can justify why they have to charge higher price. In absence of that, there's always going to be, OEM 1 may be willing to pay for local, but then he's paying a penalty at the market where an OEM 2 is not, right? So I think the frank matter, even for us, if you mandated local, it makes our jobs very easy, but there's no option.
So why is that not happening? I'm very interested, because there's a dichotomy in the government speak. On one side, there is a Make in India, Atmanirbhar Bharat, but on the other side, there's this genuine government policy always towards L1. And what that means is, in the end, that becomes the ethic of even the private industry, because everyone has to compete, which means the cheapest only wins, and the cheapest for the moment will be Chinese. So why isn't it happening when there's such a large push towards the energy transition that the government isn't mandating? If there's local, there should be some extra points or some protection or some preference.
So I think part of that does fall on industry. So let me also kind of put myself into the hot seat right now. I think when I speak to people in the government, what they kind of communicate is, okay, maybe we gave PLI, whether you like the policy or not, we give a lot of policies to try to enable things, but finally you guys aren't doing anything, right? Where I think the government has been very good so far in India is in terms of creating downstream demand. Now, you could do it possibly more aggressively. Maybe Delhi EV policies are very, very aggressive, right? Now, suddenly 3 different vehicle classes within 3 years are going to be seeing almost like all new registrations. It's going to go what, auto, then three-wheeler, then maybe bus also they're talking about. Now, if that happens in the largest auto market in the country and it's successful, they would have successfully created a replicable model for all major metros, right? So I think government feels it's doing a lot to create downstream demand, but finally they're saying, where is the industry people who are actually coming up? So unless there's enough capacity to satisfy demand, how do I mandate local? So I think they have their own concerns also. But with that said, we kind of also, it's consultative. So we talk about, okay, you did it successfully in solar. How did that happen? Now, same thing. There's a push from the government of India that said, I want to have so much renewable energy, right, by X date. And probably it's the first time in our history they've actually had to revise a target upwards, right? And now they're talking about even much bigger. So they're saying the solar parks are coming up now. Now we should actually start bringing in, it's ALMM, now the ALCM. So from the module to the cell, they notified well in advance, okay, now you have to, by this stage, you should make wafer. By this stage, you should make ingot. If this is successful in battery, I think it can come in the manner of energy storage. So that's where they see as a natural extension. You don't really have to kind of recreate, anything. You did it for the renewable. Now, what is ESS? Nothing but kind of an offshoot of renewable, right? So probably for EV, I don't know that they can really do anything to mandate. They can only kind of keep creating demand and wait for capacity to start up. But on ESS, there's obviously a lot of talk already that an ALBM type of policy is well in the works. Now, obviously the way we have to see it is ultimately ESS economics are very simple. 70% of the value addition is coming if you make cell. If you don't make cell, the max value addition you can do is like 25 to 30%. So at least what I've seen so far, there's definitely going to be a push to immediately do that 25%. But you're really not solving the problem unless you notify in advance saying, I want cells made by X date, right? Because that's the bulk of the pie. Now, are there enough people who are willing to make cells in India? Now, PLI, the third phase has kind of come out. It's only for ESS, so we'll have to see. But PLI, no PLI, I think we're very keen to go ahead with the ESS. So
you mentioned PLI a few times, and you talked about how 3 years ago you didn't apply. In fact, you weren't part of the program, unlike many other companies. Was that a blessing in disguise for you? Because it gave you the freedom to do whatever you wanted to do, didn't put pressure on you to deliver by a particular date?
So just maybe small correction. We did apply.
Okay.
We didn't get through. So
right.
There
Which
was
is surprising.
I don't know. You can see it in multiple ways. The price, the bids that won the PLI capacity, I think were significantly lower and more aggressive than whatever we put. So if we were to receive that benefit, there's a doubt whether it's really a benefit to us. And in the meantime, at the time, obviously we were quite concerned that the penalties were actually, in some cases, the quantum of penalty was more than the quantum of benefit. Okay. So that's something that we looked at. Of course, there's no penalty to speak of now. So that's a different story. But I think it is freeing because today we don't really have to depend on any timelines. The only timeline we depend on is our timelines. But with that said, I think PLI, the third tranche, is coming out. It's very much geared towards ESS. It's a bit more limiting in terms of the max capacity a single player can take. But I don't believe they've fixed all the issues from the former PLIs.
Let's talk about scale in India then. How big does a gigafactory have to be in India in order to meet the economies of scale to be competitive? Is it 2, 5, 10, 20 gigawatts? What does your own calculation tell you?
There's some caveats. I think when we looked at earlier, maybe 1.5 years, it's a little bit dated now. So if anything, the economies of scale would have only increased. But even when we started setting up the factories around here, we always thought 8 to 10 gigawatt hour was a fairly good scale, beyond which you can still get benefits on material purchase and all, but it becomes more incremental. So I think 8 to 10 gigawatt hour was a very ideal capacity for the type of segments we were looking at. Now, if you look at a market like the United States, there's some very small players who are they're not making gigafactory. In fact, our CQP would be like their factory. But they're catering to industries like defense and aerospace and very niche segments that have the pricing power in which that capacity is enough for them to be profitable. So for us, at least, we're largely focused on pretty mass market applications, right? Like electric vehicles and energy storage. So this would probably be the right more
Yeah.
closer to the right number.
So talk about the United States, Vic. I was there last week. We supply the battery industry in India and in the US. And what struck me is how different the United States has become over the last 3 years when you look at the battery industry. Here you have companies such as yourselves that have made aggressive bets on future chemistries is what I call them, not necessarily lithium, but it could be sodium, could be anything else. The United States, in its extreme focus of deleveraging from China, has completely quit almost the lithium battery industry, and the lead acid industry is going gangbusters. Here we see our lead acid demand go down. There is the other way around. All the lead acid companies are betting big. How do you read this? Is this a short-term blip because of geopolitics, or are we going to see two very different progressions in the battery industry?
I hope it's a short-term blip, because eventually, just to kind of deleverage and geopolitics, you shouldn't stop your entire innovation cycle in a country. And not to say lead acid is a dated or gone technology. Obviously, we're very much incumbent in that technology, but there's definitely an argument to be made that if you go too far back and you dig too deep in existing technologies, only to kind of avoid falling into somebody else's supply chain, somebody else's overall value add. This is something they can do themselves, right? I think there's nothing that stops a country economy the size of the United States from recreating everything. Granted, it'll be more expensive. It may take longer. But their pricing power is also a lot higher. They have the economics to absorb higher costs. Whereas India, the challenge is always you don't have the economics to absorb higher cost, and you have to find a way to kind of still compete. So I think these are. I would definitely feel that they're going a little bit in the wrong direction by completely levering away from renewables, electric, but it's not. I think there are some still good efforts that are happening there.
Made, yeah. Watching your company, since I have the privilege of being able to interact with the battery industry across the world, from Australia through to the US and UK and India, you are a very unique company because you have had the courage to lean into the discomfort with the new generation of you and your brother running this business, and you're actually disrupting yourselves. You're a lead acid company that has invested heavily in lithium and are betting big on the future, and I'm not worried about the disruption. You want to be an energy storage company. You're not a legacy company in that instance. So clearly, lithium will cannibalize some of your lead acid business. So how do you see that working between now and 2030? Which part of your lead acid business is going to move to your lithium business?
I think first, it's not that we have no apprehensions towards it, right? I think we know that we're kind of playing a little bit with fire when we're trying to do this. But at the same time, I think we are clear, at least, when we keep doing this annual exercise, go through our strategy, really understand which segments are at risk of being, seeing a technology changeover. There are clear areas where this is happening. Telecom is number one. The area that's already happened, right? So today, whatever lead acid capacity we're still selling in telecom it's very nominal. It's only for replacement of existing sites. But otherwise, you can say it's as good as 85-90% already converted to lithium, our own business. And the positive, we used to be the leader in lead acid for telecom, and now we're the leader for lithium in telecom. But with that said, I think it's very simple, right? If we believe something is going to happen, either somebody else can do it to us or we can do it to ourselves. So for us, this is, like you mentioned, we're third gen in this business. I didn't create all this. I didn't, build this from scratch. It's incumbent on me not to take over and let it all go away. So I think there's a sense of responsibility that more than short-term numbers like margins and profitability, if I've walked into a business that's been around for 40 years, I should ensure it stays around for another 40 years.
So I'm going to probe you a little bit because I've watched your company for a long time, and you don't get the energy when you walk through Amara Raja that it's a legacy company. You're able to be big and nimble at the same time. Compare yourselves to any lead acid battery company. There may be a couple in India that are also chasing your dream and trying to disrupt themselves. But when I look at it around the world, the lead acid company finds it impossible to develop the mindset, the nimbleness, the skill sets, or the appetite and investment and risk to move towards lithium-ion. What is different about Amara Raja that has allowed you to make this move where we're sitting in this factory here today, 3 years after you dreamt of it first?
Well, I think there's a couple of reasons. A lot of success does fall on our chairman, right? So Jay's always had that challenger mindset. So even when he's winning at something, I think he always feels, he plays the role of the rebel. He plays the role of the challenger. So we've always kind of felt that, we never really felt like we made it, right? So we have to keep challenging, challenging, challenging. It does help that our nearest competitor is still a little bit bigger than us, right? But another thing beyond that, we did kind of separate out the teams, right? I think we didn't try to kind of assume that everybody can do everything. So we created a completely new subsidiary. That subsidiary was fed with some of our longstanding talent, but a lot of the people who are working on this are very new from this background, from this industry. So they bring that urgency, right? That this is something that's happening. They're like technology zealots that are like saying, renewables is the future, EV is the future. This is something that has to happen. Now, even the most progressive among, incumbent company that's doing quite well, we're not going to feel like disrupting themselves overnight, right? So I think it's a bit of a challenge we face, but at the leadership level, either between me and my brother, with our uncle, we were very, very clear that this has to be done. And more, I think there is a little bit of crossover happening. So as the telecom was kind of in the process of converting over from lead acid to lithium, the teams worked very closely together. So the same marketing teams who sold lead acid are selling lithium now. So they're just buying from a new factory. So I think that's what we kind of said. We're building new factories. You guys have always done it. Instead of buying from this factory, now you buy your products from this factory. And there's some other areas where you're seeing a little bit of penetration of lithium. Home energy is one, especially as we move away from a storage situation to like residential energy storage, daily cycling. That's where lithium starts to play a lot more of an important role. So slowly getting these teams to mingle, work together, and understand that, the future is selling something new.
Last question then, Vic. We've got a long journey back to Hyderabad through traffic now. It's so exciting to see this factory. When you talked about it 3 years ago, it was really just an idea in your head, and here we are. It's a testimony to your hard work and the vision of your team to be able to deliver this. Here, looking forward to 2030, what does success look like for you for your lithium business?
So I think starting, even where we are today, right? It's 3 years in to a very highly focused new energy journey. We're still very early, I feel. Everything we've done to now is just setting the foundation. So even when we first set up shop here, we started building out this giga corridor in Telangana. One thing we said is phase one is the only thing we're committing to hard capital. Obviously, we have a bigger vision, but phase one includes setting up pack capabilities across low and high voltage, now with an ESS capability. It involves setting up the R&D facility, the qualification plant, and the gigafactory as well, the first gigafactory, and that too only the first line in the first gigafactory. Now, if all of that is successful, which, we're definitely working very hard to make it so. I think we're not depending on luck. By 2030, I think we want to see ourselves cross that 10 gigawatt hour threshold, hopefully by a lot. We want to be working with, at least largely Indian supply chain. So qualifying more and more Indian suppliers, being less dependent on imported material, and preferably having a much better control on the kind of process technologies, type of equipment suppliers we work with to have a diversified source. So that's on probably one side of it. On the other side, today we talked about we work with largely standard chemistries because we're trying to kind of get our feet off the ground. The analogy we use is, you're running a track race. An opponent who's as it is faster than you is starting, 100 meters ahead of you. Now you need to get off the finish line, whether you crawl off the finish line, walk off the finish line. I think it's movement, right? That's the mode we're in right now, that even crawling and walking is better than standing still. So I think the analysis paralysis that did also afflict us for a short period of time is very much gone. But while we kind of master a couple of these foundational technologies and advanced cell chemistries, I think very much we want to start testing limits by, also attempting to work on some more latest generation. And I think while doing that, the idea of building like our type of R&D center, we're trying to build an institution. I'm not sitting here and saying we'll discover everything in Amara Raja sitting in Hyderabad. But the idea is we want to set up a platform of collaboration. So tomorrow it could be, most advanced research centers in Europe and the United States and any country for that matter. We're ready to collaborate. We're ready to do a lot of the work. We're set up the infrastructure for it. But eventually, I think beyond 2030, real latest cutting edge technology has to start coming out of India.
Quick follow-on question then. For 2030, where do you see sodium ion in the whole ecosystem?
So I think now sodium is something, just like ESS, we also underestimated it.
Yes.
In fact, I don't even know if we spoke about it last time we met, but for us, sodium is something that's becoming very critical in our roadmap. While you talk about the lithium chemistries, NMC, LFP, sodium finds a unique place in the mix. I think the important thing is it's part of the mix. Just like I don't believe LFP replaces NMC, I don't believe sodium is coming and just replacing anything outright. So like we have our lead acid, we'll have NMC, we'll have LFP, we'll have sodium. We'll probably have a couple of new bets also, right, on the anvil for the long term. There's a couple of unique advantages of sodium that definitely find good use in some storage applications, especially where we're less concerned with energy density. We want more cold weather performance. We also see that there's a good chance that we can start using sodium even for our original application, like SLI batteries. Compared to lithium, it has it's much more capable of mimicking lead acid type of cranking capability. One of the things that is very important for a starter battery is cold start, right? The CCAs. So it far outperforms lithium on that front. And we have already seen that there are some efforts in countries like China and Southeast Asia where they're introducing sodium for an SLI. With that said, I think it's something to add to our mix. It's not something we expect that a lead acid battery can just be replaced overnight. I think the global market for lead acid batteries is almost $16 billion. We make hundreds of millions of them a year. But sodium does have a place where I believe there's a good chance we'll use it for an existing application before we use it for a more advanced application.
Excellent. Vikram, I know that you're pressed for time. Thank you so much for having made the time for us on the show. It's so fascinating to see your dreams come to reality. And I look back to coming back when you've scaled to the gigawatt factory that you have dreamt of and to see how the journey's been then.
Thanks so much. Great to be on.
Cheers.